Find the area of the region bounded by the parabola y equal to 4x squared. The tangent line to this parabola at the point 2, 16 and the x-axis. So if we graph the parabola, say this is the parabola we have. We have the x-axis. So this parabola has a minimum 0, 0 at exactly the origin. So when x equals 0, y equals 0. So 0, 0, the origin is the minimum of the parabola y equal to 4x squared. We have the tangent line to this parabola 2, 16. So assume that 2, 16 is, say, this point. Let's draw the tangent line. So the parabola is in the red color. The tangent line is a blue one. This point has coordinate 2, 16. X equal to 2, y equal to 16. We can find out the equation of the tangent line. We find out that. And the last one is the x-axis. So this x-axis. Then the region we need to compute the area is this region. So first thing, we need to compute the equation of this one. Assume that we compute the equation of this one already. Let's say y equal to ax plus b. Assume that we got that. Then what's next? We have three curves here. Then let's divide this region into two parts by this vertical line. Say this one. Then we have two small regions. Let's call it region 1 and region 2. In the region 1, the area of this one would be, say, let's use it to be the green color. The area of region 1 is integral from 0 to something. Let's call something to be this point, say x1, 0. The y value is 0 because this point in the x-axis. So let's call this point x1. So the area will be the integral from 0 to x1 of red minus the green one dx. The area of the region 2 will be the one from integral from x1 to x equal 2. So this point 2. This point is 2. So the area of the second one would be the integral from x1 to 2 of the red minus the blue one. So let's write down as R1 and R2 to differentiate this with the number 2. Okay, let's compute that. So the first step, we find the equation of the tangent line. Ax plus b here, we will find ab. And the second, we will find x1. x1 is easy. X10 is the intersection point of this line and x-axis. And then we compute the integrals. the equation of the tangent line. Of the parabola at, what is the point? 216. Of the parabola. So recall that when we find the tangent line of, say, a curve, say y equal to f of x at some point, so recall if we have y equal to f of x, then the slope will be computed via the derivative. F prime x will give us a slope equal to x0, give us the slope at x0, f of x0. In our case, the slope at this point, so x0 is 2, but we can compute that by the derivative of fx. So fx in this case is 4x squared. So the slope 4x squared, the derivative of that is 8 times x, and at the point 216, so x equal to 2, so the slope is 8 times 2 is 16. So this means that a is 16. So the equation of the tangent line is y equals 16x plus b. Now to find b, we just need to check the point 216. So 216 is on this line, is on this tangent line, let me call it t, on t. So we have 16 equal to 16 times 2 plus b. This gives us b equal to 16 minus 16 times 2, so minus 16. So this gives us the equation of the tangent line is 16x minus 16. The point x0, x10 is when y equals 0. So the intersection of the tangent line with x-axis, intersection point of the tangent line t with the x-axis is something x10, right? So y equals 0, 16 times x1 minus 16. This gives us x1 is 1. So we have the point 10 is this intersection point 10. So now we'll compute the area of the yellow part. The area is the area of the region 1 plus the area of the region 2. The area of the region 1 is the integral from 0 to x1, which is 0 to 1. 0 to 1. 0 to 1 of the red minus the green. So 4x squared, the green is the x-axis, so this is y equal to 0. So the x-axis y equal to 0. The red minus, so the red is 4x squared. The red minus the green. 4x squared minus y equals 0. This is dx. And the area of the second one from x1 to 2. The red minus the blue. So the red is 4x squared. What is the blue? 16x minus 16. X minus 16 dx. Zero on 4x squared dx. 1 to 4x squared 16x plus 16 dx. 4x cubed divided by 3 from 0 to 1. 4x cubed divided by 3 minus 16x squared divided by 2 plus 16x. Here's x from 1 to 2. So 4 divided by 3 times 1 minus 0 plus 4 divided by 3. We have 2 cubed, 8 minus 1 cube plus minus 16 divided by 2, so 8, 4 minus 1, 16, 2 minus 1. So this one should be 4 divided by 3, 4 times 7 divided by 3, 8 times 3, 16. So this one is minus 8. This one is 4 times 8 by 3 minus 8. 4 times 8 minus 3 times 8 by 3. So we have 8 divided by 3 is the area. Okay, so the area is 8 by 3, 8 divided by 3. In this case, we did it for the integral. When we set up integral with respect to dx, we can do it to set up integral with respect to dy. So here's how we do it. We can find this intersection point, which is 2, 16. So y between 0 to 16. Y between 0 to 16. This is 16. And we can set up the interval from 0 to 16 of the blue minus the red. Minus the red dy. That is the second method we can do. And the blue one and the red one we need to write down as function x equal to a function of y. So for example, in this case, for the part x greater than 0, this would be x equal to square root of y divided by 4. And the other one is x equal to 16 plus y divided by